Okay, how to make a scatter plot. You need to identify what variable is explanatory, because the explanatory variable will always go on the horizontal axis. The response variable will go on the vertical axis. Sometimes that's the most thought-provoking part of the problem is, what do I put on which axis? Once you've got that figured out, it's pretty easy. You're going to scale your axis. Be sure that you span all of your data. And what that means is make sure your lowest number and your highest number is accounted for. And what's really cool is you don't have to start at 0. So if you're dealing with data up in the hundreds or thousands, then start with look at your lowest and highest value, and that'll kind of tell you where you need to start and stop. And lastly, you are going to plot individual data values. Remember, those points represent the individuals. And I'm just going to show these two blanks since I don't think the last recording got taken. So, okay, let's just practice here. We've got, here are the 40-yard dash times in seconds and long jump distances in inches for a small class of 12 students. Make a scatter plot of the relationship between the dash time and the long jump distance. Okay, the very first thing we need to do is figure out explanatory versus response variable. We're talking about how fast somebody can run. And then if you've never seen a long jump, what you have to do is you have to run a little bit of a way before you jump to see how long you can jump. So you need to think about which one might help predict the other one. You can kind of think of it as a cause and effect. What would you have to know first before the second one? So what are you guys thinking about that as far as how fast someone can run, dash time, and how far they can jump, long jump distance? Dash time would be explanatory. Very true, because if I were to try and do a long jump just from standing still, I wouldn't be able to jump very far, versus if I can run really fast up to the line where I jump from, that's going to help predict how far I can jump. So we're going to say the explanatory variable is dash time, and the response, what we could predict, is going to be long jump distance. Now you're going to use the rest of this space down here to draw a scatter plot, so there's no need to make it really small. Go ahead and draw a vertical and horizontal axis. You don't have to use a ruler. And let's go ahead and label where things are going to go, and then we'll talk about our scales. So we just made this decision that the explanatory is dash time. That means that will go on the horizontal axis. Leave some room for your numbers and write dash time. And put the units of measure. That means on the vertical axis, the response variable goes there. So go ahead and write long jump distance. Leave room for your numbers. And that's in inches. Identify and label. That was step 1. Now, we're going to scale the axes, and you don't have to start at 0. So what you need to do is you need to look at your data. Let's look at dash time. Let's find the smallest and highest numbers in the dash time. So the smallest number is 5.05. That's the low value, and that person is the fastest. Bless you. And the highest dash time is down here at 7.25 seconds. That's the high value, and this person would be considered the slowest out of the bunch. So I need to span the data. I need to make sure that everybody between our 5.05 up to 7.25 is included. So I know I'm going to start at 5. What do you guys think would be appropriate to count by if you need to go up to a little bit past 7.25. What do you think? Counting by one whole, just 5, 6, 7? Is that going to be detailed enough? You could count by quarters, by 0.25s, yes. Last period they suggested we count by 0.5s, and I think that was still a little bit too broad. Yeah. So how I did it on the notes in Schoology is I counted by 0.2s. So if you want to be consistent with that, in case you're looking back at that, let's just count by 0.2s. But 0.25 would also be a good one. Let's count by 0.2s. We're starting at 5.0, and I'm going to go 0.2, 0.4, 0.6, 0.8, and there's 6.0, 2, 0.4, 0.6, 0.8, and there's 7.0, 0.2, and 0.4. Make sure you've got it all accounted for. You could go back and put your in-betweens in there. But you don't even have to do that. That's just more for like me to be able to know where I'm landing. Okay. That takes care of all of the dash times. Notice we went all the way to 7.4 so that that person with 7.25 had a place to land. Now we're going to switch gears. We're looking at long jump distances. What's the shortest distance anybody jumped? 65 is our low value there. And what's the longest anybody jumped? 184. So I need to go from a little bit below 60 to a little bit above 184. And I wasn't very creative when I did this. I just counted by tens because I figured that wouldn't be terribly difficult. So I started with 60, and then 70, 80, and I just labeled every other one. 90, 100, 110, 120, 130, 140, 150, 160, 170, 180, and then I just went up to 190. Now, I doubt very seriously that you need my help plotting these points. How I'm going to stay organized, you do not have to do this, is I'm going to circle an individual. I'm going to circle the person who took 5.41 seconds and jumped 171 inches so that I know those go together like an ordered pair, and I'm now going to plot that individual. And I'll have to do some estimating, 5.41 and 171. Do not wait for me. You're not going to get anything out of just copying where my dots are. So this person is now plotted. 5.41, 171. Okay, you go through here. I'm going to take mine off the screen for just a minute. You go through here and you plot all 12 of these people. Take your time, make sure you're accurate. Yours should look something like mine, but don't turn the page quite yet because I want to ask you some questions about this when we're all done. Okay, I'm looking around. Most of us are done. If you're not done, put the finishing touches on it. But before you turn the page, I bet that you already know some of the vocabulary words that we're going to talk about today. If you looked at this scatter plot right here that you just made, would you say that this had a positive or negative association? Think back to your algebra classes when you talked about this kind of thing. Why would you say negative? Yeah, so then there's that word slope from algebra, right? So it's got kind of this downward trend to it, okay? That's one of the things we're going to talk about today. Would you say that this would be linear or non-linear? Do you see things falling into a line, or is there some curvature to it? So you think curvature? Maybe that's because of the lousy job I did graphing, but it's pretty linear here, I would say. It's kind of weak, but and then do you see any outliers? Do you see anybody, an individual that's just way far away from everybody else? No? Okay, cool. So those are the things that we're going to talk about. On the next page is mainly just some vocabulary. Which for some of you is nice because there's not mathy things to do, but I know for those of you that are inclined to be better with numbers, the vocabulary is kind of what trips you up. So let's look at this page, and it says, this is how you're going to describe a scatter plot. You can describe the pattern of a scatter plot by these four aspects. There's four things that when I ask you to describe a scatter plot, you need to tell me about. Okay, don't just tell me, oh, the scatter plot looks nice. You're going to tell me about the direction, the form, the strength, and if you see any outliers. Those are the four things you're going to write about if your homework says describe the scatter plot. Now let's go through these really quickly. Your direction, your options here are, if you see that it's generally increasing, both variables are increasing from left to right, then that's a positive association. It's increasing. Both variables are increasing. If one of your variables increases, just like our dash time, as you get slower and slower and slower, the less far you are going to be able to jump. So as one variable increases and the other decreases, that's going to create a negative association. Sometimes the data is going to be so completely scattered, you can't see whether it's increasing or decreasing, so we would just say that that has no association or relationship. Instead of the word association, we could say relationship between the variables. So if I ask for direction, I want positive, negative, or none. If I ask you for form, we're going to keep this very simple. If you notice that things kind of fall along a straight line, even if it's weak, if it's linear, then you're going to put linear. If you see any sort of curve to it, we don't have to be specific and say things like exponential or logarithmic or quadratic. You can just put nonlinear, which is kind of nice compared to the algebra scatter plots. You had to be very specific on the type of function. So it's either linear or not. That's for form. If I ask you how strong it is, then you can kind of stare at these and figure out what strength is talking about. It's how closely along that linear pattern the points fall. Well, right here, almost every single dot is on that line, and we're going to talk about linear regressions later on in the chapter. So this would have a very strong strength. This one's kind of somewhere in the middle, so we're going to call that moderate. Where you can clearly see that they still fall into a line, but they are a little bit more departed from where that linear regression line would be. And then be sure you understand that even though these seem really scattered, they are generally like increasing and increasing and increasing. So there is a linear trend here, but it's just weak. Now, these are not your only options for strength. You can use words like fairly strong or moderately weak. You can kind of blend them together. So there are different ways to describe these. And then lastly, you guys know by now how to spot an outlier, but I want to be really specific here about something, okay? I want you to add some writing here. I want you to write that outliers can strengthen or weaken correlation, which we're going to talk about on the next couple of pages, but I want this to be in your notes now. I want to talk about it now. I don't want to wait. So outliers can either create a stronger correlation or a weaker one. So if you see an outlier, let's say, look at this scatter plot right here, okay? And I'm just totally making this up, so bear with me. You see an individual that's like way down here, okay? Well, that person is definitely an outlier because they're way far away from everyone else, but it kind of pulls all the dots closer to that line that I would draw through here. So if your outlier falls within the pattern of everybody else, then that would strengthen correlation. So that's if your outlier is within the pattern of other data values. Within the pattern of other data values. If it falls in line with everybody else, even if it's far away, then it's going to strengthen correlation. It's going to make your R value stronger. We'll talk about that on the next page. If you see like this weirdo right here is clearly not in the same pattern as everybody else, so that would actually weaken correlation. So I want you to tell yourself correlation gets weaker if that outlier is outside the pattern of other data values. Outliers don't necessarily throw everything off. Sometimes they fall within line of everything else, and they can actually strengthen your data. Okay, so these are the 4 words that you're going to use to describe. Let's turn the page and practice that really quickly on a couple of these. Notice that the directions just say to describe the relationships shown in the scatter plots. So we need to list very specifically, we need to talk about direction, form, strength, and if we see any outliers. You don't have to write big fancy sentences and phrases for these. Let's talk about direction. If your options are positive, negative, or none, what would you say about the weight? Let's say this is about diamonds. How many carats your diamond is and the price here. Would you say that has a positive, negative, or no association? Positive, right? Because it's kind of trending upwards. The bigger your diamond is, the more it costs. So they're both increasing. That would be a positive. If I ask you for form on a quiz, your options are either linear or nonlinear. So do you see these falling into a straight line, or is there a little bit of curvature? This would be one where you would see a little bit of curve here. And if you kind of want to draw that in for yourself, generally here's what I see. It's just a little bit of a curve. So non-linear. How strong is this association? If these dots are really, really close together here along the curve, and then they kind of start to get maybe a little bit more scattered as we increase the carats and the price. What would you say? And you don't have to say weak, strong, or moderate. You can blend them. What do you think? I think moderately strong is fantastic. Because most of the data values are falling into the same pattern. Do you see any obvious outliers? Any data values that are way far departed from the other ones? I don't. I mean, even this guy up here still is within the pattern. So I would say no obvious for outliers. So there is a relationship here between the weight of a diamond and how much it costs, for sure. Now, this is the one that we created on the first page, dash time and long jump distance. Let's describe that. So see if you can stay one step ahead of me here. You will have a quiz on this someday. And I'm going to ask you, there'll be a little pull down menu, and I'll ask you for each of these. I will try to make it obvious as far as like strength or form. I'll make sure that it's not one that you have to stare at and go, well, I really kind of can't tell. What did you tell me on the first page was the direction of this? Positive, negative, or none? Yeah, you said negative, right? As dash time increases, long jump distance decreases. So as one goes up, the other goes down. That's a negative association. I'm saying that because I know you're going to have a test question that sounds like that. Form, linear or non-linear? Those are your only options. Yeah, I think somebody said it. So even though it's really weak, okay, they're not all in a tight, nice, neat little line here, there is a linear association happening here. There's no curvature to it. I actually just gave that away. This next one, strength. Would you say strong, moderate, weak, fairly, one or the other? What do you think? Moderate, moderately weak. Okay, I like either one of those. Or we can even say fairly. Just so you know that that's an option. If you're looking back at your notes, you don't have to stick with the whole moderate thing. Fairly weak. And we already discussed the fact that there weren't any obvious outliers. There was nobody in this class of 12 that was just way far away from everybody else. Okay, so that's all I've got on scatter plots and how to describe them. Now we need to talk about the other half of the notes, which is correlation. Correlation helps you, out of those four things that we just talked about, it helps you give a more detailed answer for strength and direction. That will be a test question. What does correlation measure? And it measures strength and direction. It tells us how strong, and it tells us is it positive, negative, or none. Okay, let's write those two words here in the blank. Correlation measures the strength and direction of the linear relationship between two variables. Again, that will be a test question. Know that correlation tells you how strong and which direction the relationship is. And then we've got these little bullet points. I created a test question out of these too. Here are some different characteristics of R. Correlation is represented by the variable R, okay? And I want to tell you that R is always going to be a number between -1 and 1. So on a test, it might look like this. I'll give you a question and I'll say, out of all of these answer choices, which one is not true? So you'll have to go through there and you'll have to make sure you know all about R and pick the one that's not true. R is always between -1 and 1. And notice it is allowed to be -1. It can actually be +1. So the or equal to signs are thrown in there. The next two I think are kind of a no-brainer. R is going to be a positive number for a positive association. So you might get something like 0.8 or 0.3 or 0.25. If it's positive, then you're talking about something like this that has a positive trend to it. It's increasing. Both variables are increasing. R is going to be negative for a negative association. So you'll have negative decimal values like -0.8, -0.2. I say decimal values again because we have to be sandwiched in between -1 and 1. There is no correlation of like 5. That's just not a thing. Okay, there's a huge typo coming up that I hope that you're paying attention for. Values of R near 0 indicate a very weak. Change that to weak. Can't believe I did that. I meant to fix it. Values of R that are really close to 0, so like 0.1, -0.1 on either side of 0, are going to show a really weak linear relationship. The closer to 0, the weaker it is. Now, when you get to the very extreme values, all the way out to -1 and all the way out to 1, those are really strong values. As a matter of fact, -1 and 1 are only going to show up in a perfect linear relationship. So the closer R is to these, the stronger the relationship. Weak is in the middle, strong is on the outside. We're going to actually start putting numbers to all of this. So turn the page and we're going to try something here. There are 8 scatter plots in front of you. Some of them are really, really strong and some of them are really weak. Some are positive, some are negative. And so you have this little options box. And what I want us to be able to do is match each R value with its graph. So let's start with these two. Let's start with the extreme +1 and -1. So unfortunately, I forgot to maybe put some letters to this. So use your words and tell me where you see the strongest positive correlation. This is really strong, isn't it? But is it positive? This is negative, so if it's really strong but negative, what could we say R is there? -1. But because it has this downward trend, it's got to be negative. Which means this one on the other end of the spectrum has to be +1. So I'm going to mark those out of my little box here. Just kind of mark them out as we go. Then let's go right to the middle, the weakest one. Where is the weakest correlation out of these 8? Yes, it's going to be 0. And which scatter plot is that? Bottom left. Very good. See how weak that is? I wouldn't even be able to say positive or negative. Well, guess what number is not positive or negative? It's 0. So that's very, very weak. And then I'll tell you what, I wasn't very creative here. I just put them in order least to greatest because I kind of want you to have a really good example to reference. So like this -0.99, that's really close to -1. So it's going to be really strong, but not quite perfect. That's why it's going to go with this one. This one's still really strong. It's almost perfect, but it's just a little bit looser, you can see. What do you think would come next? What do you think I want you to put here? -0.9. So it's still really strong, but it's not as strong as the one before it. And then we get even weaker, but it's still negative. So what do you think would go here? Yeah, this one would be kind of halfway in between perfect and super weak. So kind of moderate there. Okay, and then we've got our 0, and then we just start with our positive trends. What would go here out of the 2 we have left? 0.4 would be moderate to weak. And then what about the stronger positive one? 0.8. Good. It's really easy when you have a box to choose from. What we're going to do now in the last four is we're just going to estimate. We're just going to pull it out of thin air. But we know the rules. If it says to estimate R, we know we have to be choosing numbers between -1 and 1. We know we have to use our eyes to determine if it's positive or negative, and then we also have to use our eyes to decide if it's strong or weak. So this first scatter plot here, I would say that this is fairly strong. I'd say it's almost kind of like this example up here. So if we're going to totally estimate R, let's put that R is approximately 0.8. Now, if you're a student who you're working on your homework and you put 0.7 and my answer key says 0.8, then you're just fine because it says to estimate, so somewhere close to that. It's positive 0.8. And then it says interpret the value of R in context. Okay, let's look really quickly. We've got boats registered and manatees killed. As the number of boats registered increases, manatees killed increases. So I would say that there's a strong positive association. And I'm just going to write on top of the scatter plot, you guys, so bear with me. There is a strong positive relationship between the variables. Now I'm going to throw in a new vocabulary word that I know you're going to need on a test, so bear with me, okay? We have to talk about something called causation. Just because we see a relationship does not necessarily mean that one causes the other. So let's look at these two and talk about it. The number of boats registered means that basically more boats that are in the water, the more manatees are killed. Do you think that the boats registered, the number of boats, causes the death of manatees to increase, or do you think that there are other extenuating things that might cause manatees to be killed? And it's kind of your opinion. You think that other things, okay, could you maybe give an example of other things that could also be going on? You know, boats, more boats are in the water, manatees are getting killed. It could be just pollution in general. The more people that are out there, the more polluted the water. So it's not necessarily like boat injuries or anything like that. So let's put that there is possible causation, because we're not going to rule it out, but we also don't know that it's a definite thing that the boats are what's causing the manatees to die. We do know that as one increases, the other one increases, but there's not necessarily a for sure causation here. Okay, let's scoot on over here. First thing I want you to do is be able to estimate R. Is this positive or negative? It's negative. Is it strong, weak, or somewhere in the middle? Somewhere in the middle. So somewhere between -1 and 0, what do you want to put? We could put smack dab in the middle. We could put -0.5. That works for me. We're talking about the number of classes that people miss and their exam score. So the more classes you miss, what happens to your exam score? It goes down. Okay, let's talk about causation. So first thing I want you to put is moderate negative relationship technically that's between number of missed classes and exam score. So there's a relationship here, but again, and sometimes the answer is yes. Sometimes we're going to say, yeah, if you miss classes, then that's going to cause your exam score to go down. So we would put causation. What do you guys think about this one? It's what?
There's like other factors that go into like.
Do you think that missing classes is going to cause you to have a lower exam score? Not necessarily for some people, right? But I still think it's possible that that one is causing the other. So let's put possible again. Okay, here we have exposure to advertising and purchase intention. What that means is, as you're scrolling through your social media and you see ads more and more and more, as that increases, your desire to purchase something or your intent to make a purchase is also increasing. So even though it's weak, there is a relationship there. So what do you guys want to put for your R value? If you're just pulling one out of thin air and you see that it's positive and weak. 0. What did you say? 4? I think it's even weaker than that. 3 or 2 maybe. But it is positive. Now the weaker your correlation gets, you can pretty much guarantee that your causation is also starting to diminish. So somebody actually brought up a really good point that he said, as a matter of fact, the less ads I'm shown, if I was shown less ads and I wasn't just inundated by it all the time, I'd actually be more likely to buy something. So here we're going to say that this has a weak positive relationship, and we're going to say no causation. Just because you see a bunch of ads, that's not going to be the only reason you want to purchase something. And I feel like I'm not doing a very good job explaining the causation thing today. Okay, last one, and it's very vague. It says last year's percent return and this year's percent return. Maybe that's talking about either return on investment or tax return. I don't really know. Kind of doesn't matter because what do you see going on here? Craziness, no association. What would our R value be? Let's put 0. Weak, no correlation. And because of that, there's for sure no causation. Last year's percent return, whatever that means, definitely has no bearing on or no cause and effect relationship with this year's percent. And we can see that because of no correlation. Okay, that's it. Your assignment is very, very short. You can definitely finish